Hi everyone, welcome to Everyday, your daily stop for virtual reality content. My name is Dee, and sorry for the delay in getting this up. I'm doing two videos today to make up for it. This is the first one. The second one's going to be a tour of the new DK2 version of Titans of Space, so hang out for that. This video is going to be going over another development tutorial. We're going to be talking about in the Unity Game Development Toolkit how to create a targeting reticle that works well in virtual reality. If you're not familiar with targeting reticles, they are those little things they draw in the middle of the screen, for example in first-person shooters, that tell you where you're aiming. They make it a lot easier to aim precisely and to know exactly what you're aiming at and not accidentally hit something else. This is particularly important, I think, inside the Rift because your eyes look around at different portions of the screen inside the Rift, and if you don't have some kind of targeting reticle, you're going to be pretty confused when the thing that you're looking at and you click, and then that's not the thing you interact with. In the long run, I think reticles might kind of go away as we get more hand-based interaction, and we can start pointing at things with our hands to select them rather than having to point at them with our heads. But I think it's a good place to start and a good way to adapt older titles that were monitor-based, which relied heavily on reticles. So without further ado, let's jump into developing reticles in the Unity Game Development Toolkit. Now, before I do that, I want to go quickly over Oculus's guidelines regarding reticles. They actually have specific advice on this in their best practices guide, which you can look up. Just Google Oculus best practices guide. And what they say here is, I'm just going to read this. Targeting reticles are an excellent illustration of adapting old paradigms to VR. While a reticle is critical for accurate aiming, simply pasting it over the scene at a fixed depth plane will not yield the reticle behavior players expect in a game. If the reticle appears at a depth plane different from where the eyes are converged, it is perceived as a double image. In order for the targeting reticle to work the same way it does in traditional video games, it must be drawn directly onto the object it is targeting on screen, presumably where the user's eyes are converged when aiming. The reticle itself can be a fixed size that appears bigger or smaller with distance, or you can program it to maintain an absolute size to the user. This is largely an aesthetic decision for the designer. This simply goes to show that some old paradigms can be ported over to VR, but not without careful modification and design for the demands of the new medium. So, just to briefly explain what this means. So, it says pasting it over the scene at a fixed depth will result in double images, and I'll show you what this looks like in a minute. But the idea is that if you have your reticle, say, floating in the air a meter in front of you, and then you look in the distance, your eyes will converge in the distance, and the reticle a meter in front of you, they'll no longer be converged properly on, and so it'll appear, your left eye and right eye will see it differently, and it'll float apart into this double image. Conversely, if you put the reticle in the distance and you look at something up close, again, they won't be converged. Your eyes won't be converged on the reticle, so it'll form a double image. And then they talk about fixed size versus an absolute size. What they mean by that is that you can make the object with the reticle on it just have a fixed size and it never changes. And so when it's very up close, it'll be big, and when it's far away, it'll be little. And sometimes that's nice, like if you have like a laser pointer or something, that's kind of how they work in real life. You shine a laser pointer on your hand, it makes a pretty big dot. You shine it on the wall across the room, it makes a smaller dot. So it makes sense for that kind of thing. On the other hand, typical reticles that you see in monitor-based games don't change their size based on what thing you're aiming at. They have a fixed size on the screen, and we can do that as well. And I'm going to show you both of those approaches. So let's go ahead and jump into Unity. So I'm going to start by going to File menu. By the way, I have a mouse cursor thing, so if you see a red circle around my mouse, that means a left click. If you see a blue circle, that means a right click. So I'm going to go to my File menu, do a new project, and this will be Reticle. So I'm starting up my Reticle project, and I'm going to go ahead and get rid of the default camera, since I'm not going to be using that. And I'm going to pull in the Oculus resources, or the Oculus prefab, so that I can use the Rift in this application. So I'm just going to go into my OVR SDK, OVR Unity 042 lib. This is the most recent version at the current time. And I'm going to actually drag in both of these packages. So the first package is Oculus OVR player support. Actually, I think I just need the second package. I think the second package includes the first package. So we're going to be building this on top of the existing Tuscany demo, just to have an environment in which to try out our reticle. And import. So I just clicked and dragged the Oculus Unity Integration Tuscany demo.unity package onto my Unity window, and it is busy importing it. And once that's all imported, we're going to go ahead and create a quad that our crosshair will be a texture on, a transparent texture. And I'm going to start by demoing what happens when you do the simplest possible thing, which is to just float the reticle in front of your face at a fixed distance, like right in front of the camera. After we do that, I'm going to talk about how to make the reticle adjust its distance based on what thing you're looking at. And finally, I'm going to talk about some tricks on how to make it draw correctly on top of other things, and some tricks for adjusting the scale based on distance in some different ways. This is really taking a while. Come on, Tuscany, you can do it. Tuscany is a fairly large demo. It takes a little while to import. And there we go. The Tuscany import is now complete. And I'm just going to jump into here and find the scene. So it's not under OVR, it's going to be under Tuscany. There should be a scene. Here we go. VR demo, Tuscany. Don't bother saving that scene. There we go. So here's Tuscany. And it has all the familiar environments that if you've seen Tuscany on the Rift before, this is just the standard Tuscany environment with all of, this is the Unity version of Tuscany. It has the fireplace and the fountain and nice things like that. And the starting location is over here where this camera is. And there's our house. There are the trees. I'm just holding down the right button and then using my WASD keys to move around. Holding down the right button makes it kind of like a first-person shooter game type interface where you hit W and S to move backwards and forward. You strafe with A and D, and you turn your mouse to turn the viewpoint. So it's pretty straightforward if you're already a gamer. And I'm going to go ahead and drop into here the plane that are... So I'm going to use a quad. A quad is basically just a rectangle made out of, or a plane made out of two triangles. And it only has one side. So let's check out this quad. Where are you, quad? Get over here. Okay, I'm going to move the quad over where I can see it. And can I see it yet? I can only see it from this side. So quads are one-sided. I can see it from the front, but not from the back, because that is the nature of a quad. And what I'm going to do is I'm going to put a texture on here that's going to make it look like a reticle. It'll be a transparent texture that you can see through. So let me see here. I'm going to actually switch to Photoshop for that. And there's the pretty splash screen. Going to make a new file. Going to make it just 5 by 5 pixels. I'm going to do kind of a Half-Life 2 style reticle. So I'm going to have a little orange cross. All right, where's my color? Color. That seems like a nice color. Bright orange. Okay, I'm going to use pencil. There we go. And there's my crosshair. And I'm going to just save that. Actually, before I save that, I'm going to increase the image size. I want to make it a little bigger. And so that the edges remain sharp, I'm going to set it to nearest neighbor, preserve hard edges when I resize it. And here's our crosshair. And let's go ahead and save that. Okay, I went ahead and saved this image as crosshair.png in my documents directory. And now I'm going to import it into my assets. I think I'm going to import it under textures. Seems like a good place. Import new asset. Documents. and crosshair, crosshair, crosshair. So here's our crosshair texture. Now, this texture has transparency, so I want to indicate that. The way I'm going to indicate that is I'm going to scroll down here and check alpha is transparent. So that tells it that the parts that were transparent in the original PNG image are going to also be transparent in the texture. I'm going to apply that, and there we go. So that's what it should look like. Notice the checkerboard grid here. This indicates the transparent parts of the texture that we can see through. And now I am going to create a material. So I'm going to, where am I going to put that material? I'm just going to put it here with the texture, I think. So I'm going to do create material in the asset view. And I will call it crosshair, or crosshair material to avoid confusion with the texture. And when I have it selected, it will actually, it will have a space here for the texture and some other options for the material. So I'm going to start by dragging the texture into the texture space. So far, so good. Now I'm going to start with my shader set to unlit and transparent. So what this does is unlit means that this square doesn't have to be lit up by a light in the scene for me to see it. It will just always be displayed the same regardless of lighting, which is what we want for a reticle like this, because the reticle is not really part of the scene, so we don't want it to be lit by the lights in the scene. So I'm going to set the unlit, and transparent is so that we can see through the transparent parts of the texture. If I were to set it to just regular unlit, then I'll show you what that'll look like. So I'm going to go ahead and drag this material onto my quad. So right now it doesn't look like anything. I didn't mean color. What I meant was to pick texture. Yeah. So if I just do texture, I just kind of get this orange square, and that's certainly not what I want. So I'm going to go back and I'm going to pick unlit, transparent. Now we have our reticle, and we can see through it to the scene behind it, which is what we want. The reticle doesn't have any code behind it that will make it move yet. So if we were to start Unity right now, this cross would just be floating in the air here. And if we walked over here, we would be able to like look at it, but that's about it. So that's a good start. Now we need to do the scripting. So I'm going to start with a very basic script that's just going to float it out right in front of us, right in the middle of our view at a fixed distance. So to do that, I'm going to do add component scripts, and well, actually add component new script, and it'll be C#, and I'll call it reticle. Okay, so here's our reticle script. Now to edit it, I'm going to click on the little gear icon in the upper right of the reticle script component and click edit script. And this will bring up our script editor, which by default is MonoDevelop. Unity also works with other script editors like Visual Studio, which I tend to use most of the time, but MonoDevelop comes with it, and it's reasonable. So update is the function that's called once per frame. So every frame we're going to update the position of this reticle. So I'm going to do a couple simple things. First of all, I'm going to add a property that will contain the camera that we want the reticle to be facing. So I'm going to call it public camera, camera facing, like that. So the reticle will be rendered, its position will be with respect to this camera. And since I've made it a public property, I'll be able to drag from inside of Unity, I'll be able to drag and fill in that field. I'll show you that in a minute. First, we're going to do the code to update its position. So this is C#, which I'm most familiar with. It's also available in JavaScript or Boo. Either of those are fine. It'll all be very similar in all those languages. So I'm going to type transform dot look at camera facing dot transform dot position. So what this does, transform is is going to be transform is an object or a property of the reticle object, since this script is on the reticle. So this is shorthand for this.transform.lookAt, where this is the quad that has the reticle texture on it. And lookAt tells it to rotate itself so that it's facing a particular point in the world. And the point that we tell it to face in the world is the position of the camera in the world. So that just makes it so it rotates toward the camera. So no matter what side of the camera you are on, it will show correctly. Or no matter what side of the reticle, like no matter which way you're looking, it'll always rotate to face you. And additionally, because the quad can only be seen from one side, and if you just do lookAt, it'll actually face its backside towards you, which is the side you can't see. So that's not useful. So we're going to rotate it around a little bit. And the way we're going to do that is transform.rotate. And I'm just going to rotate it by 180 degrees in the Y direction. Or not the Y direction. What is this? Yeah, the Y angle. And so this will be okay so far. Let's actually go ahead and go see what this looks like without any other changes. So I'm going to save this, Control S, and switch back to Unity. All right, now we've got our reticle script set up for this object. But before we can actually try it out, we have to set camera facing to an actual camera in the scene. I'm going to go ahead and go to my hierarchy view. I'm going to just type in camera. And it will find camera left and camera right, which are the left and right eye cameras for the Oculus player. So either one of them will be fine. I'm going to click and drag camera left over here onto my camera facing variable. So it'll face the left eye camera. And that looks good to me. Now I'm going to save my scene, save my project, and let's build. I'm going to go to build settings. I'm going to make sure development build and script debugging are checked. These are just going to be handy for debugging later on. I may not show using the debugger in this video, but it's handy to have these features. And I'm going to click on the build button, and I'm going to save this as reticle.exe. The name doesn't really matter. And it'll take just a second to build, and then we will start it up. All right, here's our reticle.exe, and here it created reticle.directDrift.exe, which is the one we will be using. I will go ahead and click hit Control Enter on this application. That will launch it with the Startup Options box, which will enable me to determine what screen it will launch on. I am running this in extended mode today. Extended mode is just easier for recording. So display to right is the monitor that I'm on right now. Display one left is the Rift. So I'm going to pick display one left, and I'm going to go ahead and click play to start it up. And here we are in Unity. So, just as promised, here is our giant reticle floating in the air. And you will see that whichever way I go, I could go over here towards the house, and I look at it, and it's still looking at me. And I could walk over here towards this tree, and then I can look back at the reticle, and it's still looking at me. Wherever I go, the reticle will always be looking at me. So that's what I want. And even if I go up or down, it will still be looking at me. If I get super close to it, actually, I should be able to... Okay, well, here's the reticle, and it turns around to face us. So that's a good first step. But what we want is when we look around, it should stay out in front of us, right in the middle of our vision. And it's not doing that right now. So I'm going to come out of here, go back into Unity, close build settings. I'm going to go back to my script. I'm going to click on Edit Script once again. And this time, I'm going to tell it to set its position to the right position. So what is the right position? The position I want is I want it to be at the position of my camera as a starting point, and then I want to move it out in front of the camera by a certain amount. And the way I do that is I grab the camera's forward-facing position. To get the camera's forward-facing position, I'm going to first get its rotation. And then I am going to multiply its rotation by vector3.forward. This will get me the forward vector of the camera, so whichever way my camera is facing. And then I'm going to multiply that by some reasonable distance, like, I don't know, 2 meters. Sounds good to me. So now it's going to stick the reticle 2 meters in front of me. And I'm actually going to move the position first and do this afterwards. It doesn't matter, but I prefer to set position before rotation. And I'm going to save that. I'm going to go back to Unity. And I'm going to do the build thing again. Hit enter, hit yes. Oops, I encountered a compiler error. Oh no! Error, star cannot be applied to vector 3 and double. That's because I use 2.0. But generally speaking, you have to use floats. 2.0F is the single precision float version of 2.0. And whenever you're using vector 3, you have to use float values like this. So just keep that in mind. All right, let's go back to Unity. I'm going to build one more time. And I'm going to launch it with Control-Enter. It usually takes about 5 to 10 seconds for that startup box to show up. So let's just wait for it. I'm waiting for you, starting box. And I did it wrong. I didn't hold Control down long enough. So let's try that one more time. I'm going to hold down Control, hit Enter, keep holding down Control until that box appears, just to be sure. Here it is. All right. Now I'm going to start it up. Here is Unity. And now we can see our reticle is floating right in front of us, 2 meters in front of us. Obviously, this is a very large reticle, and it wouldn't normally be this large, but this is just for demonstration purposes. So, you know, this is reasonable. We can use it to target things. I could be like, now I'm looking at the tree, and now I'm looking at the wheelbarrow, and now I'm looking at the sky, and the fountain, and so on. So it works as a reticle. It has problems, though. So the problem is, say I look at the sky. Say I'm targeting the sky. And if I focus my eyes on the sky, the reticle will start to form a double image, and that's not good. Likewise, if I try to focus on the crosshair here, and then the tree behind it will start to form a double image while I'm focused on the crosshair. And if I focus on the tree, the crosshair forms a double image. So you can see this if you cross your eyes to fuse the two images. This is a stereoscopic problem. And it's not actually a big problem if you're just using one eye, but if you're using both eyes, this starts to get very annoying very quickly. Additionally, there is another issue, and we're going to talk more about this more later, but if I walk up close to something, my reticle starts to go inside it. And my reticle can't tell me what it's on top of if I can't see it because it's inside something else. So that's no good. This is one of the most common problems with HUDs in VR. You have to worry about them going inside objects, or if they don't go inside the object, you have to worry about them being rendered on top of it, even though they're actually farther away than the object. So this is all some interesting problems, but the first problem we're going to fix is we're going to make it so that the reticle is just as far away as the object the reticle is pointing at, so that we don't get that problem with double images. So let's go ahead and get out of here and get back into Unity. And in order to fix this, I'm going to edit my script again. And I'm going to use the raycasting functionality of Unity in order to identify the closest object in the direction that the camera is looking. So I'm going to create a ray to cast. My ray will have an origin. The origin of the ray will be the position of my camera. And the direction of my ray will be the forward-facing direction of my camera, which I have conveniently already computed right here. That's my ray. And the second parameter to raycast is out raycast hit info. So this is what we're going to use to collect our information about what the ray hit. So raycast info, or raycast hit, I'm going to just kind of call it hit, I think. Then I'm going to go out hit. So out is a C# syntax. That means this is an output variable, which is used to return a value from the function. So I'm going to close that parenthesis. And the reason this is inside an if statement here is because if it doesn't hit anything at all, then raycast will return false. And we need to do something different in that case. This can happen, for example, if we look up at the sky. There are no objects in the sky, so any ray we cast at the sky is not going to hit anything. So I'm going to go ahead and set the distance. So I'm going to keep track of how far away I want my reticle to be. Here, I'm just going to set it to hit.distance. That is just the distance away from me that the thing that the ray hit is. That the thing that the ray hit is. So if it's the distance from the camera, say 100 meters from me to that object that it hit, hit.distance will be 100 meters. And if it doesn't hit anything at all, in that case, I'm going to do something. Is this number? Yeah, it is. The tabs are being a little weird. Okay. So if it doesn't hit anything at all, then I'm going to set distance to camera facing dot far clip plane, and I'm going to set it to something a little bit less than far clip plane. So far clip plane is the maximum distance that I can see with my camera, the camera facing here. And so if I put it any farther away than that, it would get removed. I wouldn't be able to see it because it's too far away. So I want it to be closer than that, but not much closer. Pretty much as far away as I can get it. Now, I'm going to move all this stuff down to the bottom here. And whereas before we just did 2 meters, now this is going to be distance. And we're good to go. Let's go ahead and try this. By the way, all the scripts are going to be linked in the image description, so you can inspect them at your leisure and use them in your own projects. So you don't have to be copying everything down off the screen, but I do recommend you follow along so that you can learn more about the process. Just going to build. I'm going to skip right to the part where I have the application running. See you there. All right, here we are in Unity, and here we have our crosshair. And the first thing you will notice is it is not really working. I look around and sometimes the crosshair gets farther away or gets closer, and other times it just kind of hangs out in the air in front of me. And the reason for this is fairly subtle. Notice if I walk up to the crosshair, I can actually run into it, and I can't go past it. And the reason for this is because the crosshair, when I created that quad, I created it along with a collision volume. And that collision volume is telling it that when I look in the direction of the crosshair itself, that ray that I'm casting is hitting the crosshair. So it's putting the crosshair at the distance of the crosshair, which means it's not moving. If I move my head super quickly, then I can get my head off the crosshair long enough for the crosshair to change distance. But after that, it gets stuck. So in order to fix this, I'm just going to do the simplest thing, which is to remove the collision from the crosshair. I'll show you how to do that. I'm going to click on my crosshair. I'm going to find the mesh collider. I'm going to click on the gear in the corner and just click Remove Component. Now there's no more mesh collider. Nothing can collide with it. And in particular, the ray casting is not going to collide with it. And I'm going to build, and I will see you back in Tuscany. All right, now with that collision boundary gone, we're in much better shape. I look at the house. The crosshair hits the house. I look at the fountain, it hits the fountain. I look at the trees, it hits the tree. I look at the sky, and it seems to disappear. But it's not actually disappearing. It's actually just really, really, really far away. So this seems to be working. But you can see that it kind of causes a problem when you look at things that are really particularly far away. You can no longer see the crosshair, because it's too small. And when you look at things that are really close, the crosshair looks huge. Huge, absolutely huge. It's filling my entire field of vision. So I'm not a fan of having crosshairs like this that get bigger and smaller with distance. It's a little bit impractical. But it is a good starting point. And the other problem we have, you can notice this if we look at the house, is that sometimes the crosshair is going inside things. Sometimes just part of the crosshair goes inside things, and sometimes sometimes if it's an object that doesn't have a proper collision boundary, actually the whole crosshair can go inside it. I don't have an object like that here right now, but let's go ahead and walk over to this water. So notice something here. When I look out over this balcony, the crosshair is not going out on the ocean. That is not a bug. The reason that's happening is because the collider boundary for this railing actually extends up to about 6 feet high above the railing. So when I click on, when I look above the railing here, I'm actually looking at an invisible collision boundary that extends above the railing, and my crosshair is falling on that boundary. And there's really no way around that other than to have collision boundaries that are closer and better fit to the objects that they surround, so that your crosshair interacts properly with them. You can try and have the crosshair interact with the geometry instead of with the collision boundaries, but that can be really inefficient. So I don't have any really good way to deal with this. Anyway, we're going to get out of here, and I'm going to show you how to scale the crosshair based on distance. So that will be the next thing we do. So I'm going to go back into my script, edit script. Here's my mono develop. And for scaling, so the way that perspective projection is done, you take the x coordinate, you divide it by the z coordinate, that gets you your screen coordinate. And then you take the y coordinate, you divide it by your z coordinate, that gets you the screen coordinate. So if we want the screen size of something to be fixed, all that means is that the z coordinate has to go up linearly with the distance from the camera. Or in other words, the scale has to go up linearly with the distance. And I'm going to do the simplest possible thing here, and I'm just going to set transform.local scale to, let me maximize this. I'm going to set transform.local scale to vector3.1 times distance. So vector3.1 is just shorthand for new vector 10f, 10f, 10f. And so vector3.1 is shorthand for that. And what this is going to do is it's going to scale the object by the same amount in every dimension. It doesn't really have any z thickness, so that's not going to have any effect on that, but it's still going to work fine. And it's going to scale it by distance. So if distance is 1, it's going to scale it by 1. If its distance is 10, it's going to scale it by 10. If distance is 100, it'll scale it by 100. So it gets bigger as it gets farther away. And that's what we want. So I'm going to save that, and I will see you back in Tuscany. All right, here we are back in Tuscany, and our crosshair is a little bit bigger than we wanted. That's okay. The important thing is that it stays the same size regardless of how far away it is. So let's look down at the ground. Let's look at this tree here. Let's get close up with this tree. So you can see it gets smaller as we get closer and closer to the tree, and it always fills the same amount of screen space, no matter how close to the tree it is. If I look up at the sky, you can see it turns blue when we look up at the sky. And the reason for that is actually fog. It's really, really far away now, and so the fog is obscuring it. But it is still working. It's just foggy. And now we're on the wall. So you can see the size as I move from the wall to the sky is the same screen size. So that's working fine. Likewise, on the fountain, on the house, on the trees, it's just remaining the same size no matter where we look. And that is what we want. Obviously, we want it to be a little bit smaller than this. This is kind of big. And I'll show you how to do that. And the other thing we need is to deal with this problem where it keeps moving inside stuff. And the other thing we need is to deal with the fog. So I'm going to show you how to do all of that. Let's go ahead and get out of here. So first, I'm going to go into the script. And we're going to figure out how to make it smaller. So the way I'm going to do this actually is I'm going to, when I start up, I'm going to record the original scale of the object, which is set in the editor. So I'm going to record transform.localScale. So I'm just going to save the scale that was set in the editor before the application began. And then instead of multiplying vector 3.1, I'm going to multiply that original scale by the distance. And what this lets me do is now I can go over to the editor and I can get out my scale tool in the corner and I can just make it smaller. And this will just work because it will get the scale parameter when it starts up and it will use that for its scaling. I'm going to set it to 0.1 all across. So you can see it's quite a bit smaller now. Quite a bit tinier. And this should do nicely. And next, we have to worry about that problem with it going inside objects and the problem with the fog. Now these are going to be a little bit trickier to deal with. Both of these problems are due to the unlit transparent shader. The unlit transparent shader, first of all, makes it, it uses Z order in order to draw. So if the crosshair is inside something, it's going to draw it behind it rather than on top of it. And we want it to always draw on top, regardless of what it's inside or not inside. And the other thing is we want to just make it not respond to fog. And we can do both of these things by going over here to our assets, and we're going to do create shader. I'm just going to call this crosshair shader. Now, shaders are considered like an advanced feature of Unity, but it's actually not a big deal, just to tweak existing shaders. So the shader we're using right now is unlit transparent, and we're going to go ahead and go find the source code for the unlit transparent shader. In order to do that, I'm going to load up the Unity website. I'm just going to search for Unity download shader. Where are they? Here we go. So my current version of Unity is 4.5.3. So I'm going to go over here to the built-in shaders column. I'm just going to download this file with all the shaders in it. I'm going to save that. And then I'm going to open it up. Going to extract. And I already downloaded this, so this is why it's showing this. All right, here are my shaders. And somewhere under here is going to be unlit. That's not the one I'm looking for. I'm looking for the other one. Okay, I'm just gonna, oh, it's under UGUI. That's where it is. Okay, GUI unlit transparent.shader. This is the one that I want. I'm going to go to my editor. Actually, I'm going to go to Unity, and I'm going to open up this shader in my editor. So here's the shader. This is the default one it creates for you. We're just going to throw it away. And then I'm going to drag GUI unlit transparent shader over to my editor. Okay, it doesn't want to open it. That's fine. I will just open it with the File menu. There we go. And I'm just going to copy this whole thing. And I'm going to put it inside my crosshair shader. So this is what I'm starting with. And I'm going to adjust a couple things. Here it says Z-test, Unity GUI Z-test mode. Now this is the default. It says you only draw things if they are in front of other things. And I'm going to say Z-test always, which means you draw things whether or not they're in front of other things. I don't care. You always draw them in front. And fog is set to mode off in this particular shader, which is what we want. The GUI unlit transparent shader is a little bit different from the unlit transparent shader we were already using. So fog mode is already off. So I think we're good to go here. I'm just going to save this. Then we're going to go over here, and I'm going to click on my material, and I'm going to drag my shader into the shader box on my material. And there we go. I should be pretty much good to go here. All right, here we are back in Tuscany, and things are looking good. Our crosshair is much smaller and a more appropriate size now. And notice when I look at the house now, it doesn't go inside the house. That's because our shader is drawing it on top regardless of what happens, which is what we want. If I look in the sky, it no longer turns blue because of fog, so the fog is off. That is great. And everything is pretty much great here. One thing I want to note, when you roll your head to the left or right, the crosshair by default will not roll with your head. You can adjust that if you want to, just by passing to look at the camera's up direction. But I actually prefer it like this. I think it's kind of nicer when the crosshair is always upright. So you can see my crosshair is a fixed size. My crosshair goes to the distance of the object that I'm looking at, just as it should. If I go super close to this fountain, you can see the crosshair is very close. That's actually because it's hitting the collision box around the fountain rather than the fountain itself. But still quite good. And if I walk over to one of these pots or these barrels, you can see it's hitting the barrel, hitting the ground, hitting the sky. Everything's working great. Now, one issue that I have with crosshairs like this is I find it a little bit disturbing when I get super, super close to something like this and my crosshair gets really tiny. Like, it doesn't... The screen size is exactly the same as it was before, but to me it looks like it's gotten super, super tiny and like it's much bigger when I look at the sky. And the reason for that is because my stereoscopic sense of depth is giving me hints about the size of this object. It's telling me this is very close to you, so it must be very small if that is the size that you see it as. If I close one eye, it actually mostly gets rid of that effect. It seems to be about the same size when I look at the sky and at the tree. But when I'm using both eyes, I have to worry about it looking really tiny when I'm close up against an object like this. So the last thing I'm going to show you is how to do a little bit adjustment of the scale when it's really, really close, so we can compensate to some extent for this effect where it appears very small when it's very up close. So the way I'm going to do that, so first I'm going to show you a little bit of math. So here's a graph. So this is a graph I made that shows you 3 functions. So we're going to take our final scale amount and we're going to multiply it by a constant to make it bigger when the object is very close. I'm going to say that past 10 meters, we're not going to mess with it. We're just going to let it do what it's currently doing. But if it's closer than 10 meters, we're going to make it bigger. If I use 10 over x, which is this purple function at the top, that means that the object will remain exactly the same size at all distances from 0 to 10 meters. So that means that when I get really close to it, the object will be really big. When I get far away from it, when it gets far away, the object will be small. But I feel like that's going to be a little bit too big. This 1 down here is the one we currently have, where it appears to be the same screen size at all distances, which makes it look too small when it's up close. And I'm going to use this function I came up with that is between the two. It's just 1 plus 5 times e to the minus x. And this is not determined according to some kind of cool scientific model. It is pretty much just a function that I came up with that was between these two functions, and it looked fine to me. So we're going to go ahead and use this. And we're only using this again for distances less than 10 meters. So 1 plus 5 times e to the minus x. I'm going to switch over to Unity and to my script editor. And here I set my local scale to times distance. And before I do that, I'm going to say if distance is less than 10, if that happens, then I'm going to multiply distance by 1 plus 5 times mathf exp negative distance. I believe that's what I said. Sounds right. 5 to the minus distance. 5 times e. Okay, yes, that's correct. mathf.exp just raises e to a power. So that does what we want. It just does that formula. And so this is going to multiply it by a constant between 1 and roughly 6, depending on how far away it is. And this is going to make it look closer when the reticle, make it look bigger when the reticle is on closer objects. So let's go ahead and give that a shot. All right, here we are back in Tuscany. And when I look at the sky, the crosshair looks the same size as before. But if I walk up super close to this tree, you'll notice as I approach the tree, the crosshair screen size is actually getting larger. And if I look over there, its screen size gets smaller. Over here it gets bigger. So now the crosshair no longer feels really, really tiny when I'm close up against this tree, which is what I wanted. And to you guys looking at home on your monitors, it's going to look like this crosshair is getting bigger on this object right in front of me, and then getting smaller as it gets farther away. But to me, its size actually looks fairly consistent, because those stereoscopic cues are acting counter to the changes in size of the crosshair. So that's just a little hack that I did that I found to be useful. And this is all that I wanted to show you about reticles today. So I haven't tried this out yet in Unreal Engine 4. I know a lot of you would like to know how to do things in that editor as well. I wanted to show you just a little bit of how to do something GUI related in VR, a little bit of the debugging process, and how it is to go in and out of the Rift as you develop. And I hope this has been instructive. Let me know anything else that you want to see me do in Unity or in Unreal Engine. And that is all for today. Everybody have a great every day.